So now we shall begin. In the previous session, I had explained analytical and tabular method of convolution. Okay, let me rephrase it in 2 minutes, what we had done in the previous session. Okay, here it is. Okay, so in the previous session, we talked about analytical and tabular method. In analytical method, we start with the equation of convolution, that is y of n is equal to sigma k is equal to minus infinity to infinity x of k h of n minus k, right? Keeping this equation in mind, we determine the lowest index of the sequence xl and the highest index of the sequence xh. Similarly, we determine the lowest index of h of n, that is hl, and highest index of h of n, that is hh. Now we apply the equation of convolution sum. Fine. From the lowest index and highest index of two sequences, we can determine the lowest index of output sequence and the highest index of the output sequence, that is YL and YH respectively. From that, we can know that up to which value, starting from where and up to which value you can determine the output. For example, in this example, we start with 0, that is lowest index, and 6 is the highest index. So we'll start with y of 0 and we go up to y of 6. Understand? Otherwise, we can never determine that what is the length of the output sequence. Right? Fine. From there, we determine y of 0, y of 1, y of 2, y of 3 up to y of 6 using the same equation of convolution sum. Okay? Though this method is very simple, right? And it always gives you correct result, right? Because it is very easy to compute, but it is time consuming, right? So this method is little bit time consuming. In case of finite sequence, the method which takes maximum time is which one? Sorry, I need to mute. Graphical method. Okay, because in graphical method, you need to draw each and every sequence. So it takes much more time, right? So in finite sequences, normally we do not go for graphical method, right? So this method is more appropriate, but it is little bit time consuming. So we go for tabular method. Tabular method is bit systematic and it is applicable to finite sequences. In this method, we go stepwise. So all the input x of n, they are taken as columns, x of 0, x of n, x of 2, and x of 3. And impulse response sequence is taken as rows. So h of 0, h of 1, h of 2, h of 3, and so on. Fine? Yes. Now, we multiply the values of each element, right? So we assume that this is a kind of matrix, right? And we multiply each row and each column element, right? That way, we get the value for each and every element. After that, we define indices. There is lower limit and upper limit of y of n. So we take YL, the same method, YL is equal to lowest index of X plus lowest index of H. Similarly, YH is determined as highest index of X plus highest index of H, right? From there, we determine what will be the length of the output sequence, and then we separate out elements diagonally. So we formed a table, and now we separate out the elements of this table diagonally, right? For example, the table is like this. For example, the table is like this: A11, let's say, A12, A13, A21, A22, A23, right? This is column number 1, column number 2, column number 3, then row number 1, row number 2, row number 3. So A31, A32, and A33. So we separate out all the elements diagonally. These are called diagonal elements of matrix, right? And then we take the summation of those diagonal elements, right? So if you take the summation of those diagonal elements, you can quickly calculate output Y, right? So it is a very systematic method, and you can calculate the output in minimum time. Okay, so if there is a finite sequence and you are supposed to find out the output using convolution, then you prefer tabular method because it is least time taking method, right? Second, if it is mentioned, you can go for analytical method, and if mentioned specifically, then you should go for graphical method. Okay, graphical method provides you a better intuition into what is happening during the convolution operation. Okay, fine. So this was everybody from Boston. Okay. Now I will go for content of today's discussion. Today we want to study properties of discrete time convolution. We have already seen properties of continuous time convolution. We will summarize and quickly discuss properties of discrete time convolution. Okay. So what are the properties of discrete time convolution? One is the commutative property. It is exactly like continuous time. Okay. Only mentioned in this in discrete, in terms of discrete, right? So the very heart of this method doesn't change. It, see, for continuous time and discrete time, both commutative property, distributive property, associative property, and shifting property, all of them exist. Fine. Okay. So starting with the commutative property. Commutative property of the discrete time convolution is expressed as x of n, h of n is equal to h of n convoluted with x of n, which means you can interchange the order. Understand? This simply means that you can interchange the order. Yes.
Sorry for interrupting, but Thomas is asking me to this also. Sorry for interrupting, but Thomas is asking me this also. Thomas. Chance. Chance. Yeah, he was in Mumbai.
But how long did you stay in Mumbai? For example, I want to stay in my homeland. I can go there for 2 days, 3 days. Yes?
He came for exam.
I understand, I know. He's not able to appear for the examination. But how long he will do that? That is the question. Okay, fine, I will allow him, but you need to ask him that now you come anytime, only physical classes will start. Okay. So for 7 days, 8 days, 10 days, I can understand. Right? I also want to go to my hometown and stay there for 15 days. Can I do that? Is it possible? Even if all sessions are being conducted online. Is it possible? No. Right? Where is Charles? And Keyur? Keyur has not joined with Mike yet. Yes. Keyur, every time you are joining very late, you always join after 15 minutes. Next time, I will not allow you in the session, okay? Fine. Now, commutative property says that you can interchange the order. Who is that? Order of the convolution. Where is Charles? Fine. So it says that h of k into x of n minus k is also possible. For example, by definition, the convolution of x of n and h of n is expressed as k is equal to minus infinity to infinity, x of k, h of n minus k. Now you replace the variable r by n minus k. That means n minus k is now r. N minus k is equal to r, which means that k is equal to n minus r. Understand? So wherever k is there, we will put n minus r, and we will n minus k is there, we will put r. So now you replace, so you take x of n minus r into h of r, and that is nothing but convolution of h of n and x of n. Right? This and this both are same. Only difference is that here the variable is k and here the variable is r. Otherwise, there is no difference between these two equations. So you can write h of n convoluted with x of n. So that means commutative property holds. Understand? Are you getting it? Okay, now the distributive property. The distributive property of discrete time convolution is expressed as x of n into bracket h1 of n plus h2 of n. And this is equal to, you can distribute it. So you can multiply x of n with h1 of n, and you can multiply x of n with h2 of n. So you can write this as x of n convoluted with h1 of n plus x of n convoluted with h2 of n. Okay. So it is like this. You have x of n. There are two systems, h1 of n and h2 of n. And there is a sum plus here, plus here, and this is y of n. This is x of n, right? So what will happen? This x of n will go through the h1 of n. So you get x of n convoluted with h1 of n. then it is added. Then similarly, x of n goes through h2 of n. So you get x of n convoluted with h2 of n. And then they are summed together. This is the RHS, right hand side. Right hand side. Okay. And on the other hand, you can write this as this is LHS. Okay. This is left hand side. This one. Okay. It means that in time domain, the output is always calculated as the convolution of input and impulse response of the system.
Why not?
Yes. Why?
Why two responses? Why each one is this? Why not? Why not? Have each one and then
H1 of n and h2 of n. Yeah.
why we need two?
It can be 2, it can be 3. For example, if you are doing addition, let's say, then to simplify, to start with, we always do addition of 2 numbers. Does that mean that we cannot add 9 numbers? You can, right? So it can be generalized. Ultimately, it can be generalized. Okay. So here, as you can see, x of n convoluted with h1 of n plus h2 of n, and that is equal to x of k h1 of n minus k plus x of k h2 of n minus k. Not convoluted, this is multiplication. And then you can individually take the summation. So this is k is equal to minus infinity to infinity x of k h1 of n minus k plus this one. So ultimately you can prove this also. Okay, this is the graphical demonstration of distributive property, and this is the mathematical proof. Do you understand this proof? Okay. So for example, we have a system like this, 1 by 2 raised to n u of n, that is x of n, and 2 raised to n u of minus n. Okay. This is the overall signal. and h of n is equal to u of n. That means we are providing two inputs, x1 of n, which is equal to this 1 by 2 raised to n u of n, and x2 of n, which is equal to 2 raised to n u of minus n. What does it mean when we say 2 u of minus n? It means that this x2 of n is defined for negative values of n only. 0, minus 1, minus 2, minus 3, minus 4. This is 2 raised to n u of minus n. For 1, 2, 3, it will be 0, 0, 0. This is the meaning of 2 raised to n u of minus n. We can call this anti-causal signal or sequence. This is anti-causal sequence. Whereas this one is only defined for positive one. So that is 0, 1, 2, 3, 4. This is 1 by 2 raised to n u of n. For negative values, it is 0. We call this a causal sequence. Okay. So there are two inputs. One is the causal, other is the anti-causal. Fine. And the impulse response is given as u of n. Then the output y of n is calculated as y of n is equal to x1 of n convoluted with h of n and x2 of n convoluted with h of n. Understand this? Do you understand what distributive property means? Okay. Anybody who is attending online, do you have any question? Rohit, Vijay, Aman Ali, Kaushal. In Charles, you need to come back to the Rajkot, right? You already have overstayed. Fine, you missed your first examination. And by the way, 15th we have class test, right? I had postponed class test of 8 September. So 15th we have class test, and next class test, third class test will be on 4th October. That is immediately after your mid semester 2. Fine. Which one? I've already shared out all in Canvas. So this everything is already there in Canvas, including my notes. You need to find, okay, otherwise I have shared all the material in Canvas, and I'm also sharing all lectures in our MU app. Okay, you only need to find which one you want to study, right? I have given appropriate name of that file also. For example, this, if I upload it, then it is like this: Unit 2, Properties of Discrete Convolution. It is named like this, right? So you need to go there and search, because I have already uploaded, let's say 20 documents. So you need to find which one is there. Fine. What? Syllabus. So it will be unit number 2, right? And whatever is discussed by Professor Ved. Not the beginning. After class test 1. Okay. Yes. No. Your class test will be offline only, unless you have specific reason, right? Because see, last time there were few students who were not able to adjust uh, their video or something like that. Then even if you are not doing anything, I have to remove you. If I find, if it looks like there is something wrong with the candidate, then I have to disqualify that person. Yes. Out of 10, yes. It will be out of 20 converted to out of 10. So class test will be of 20 marks. During calculation, I will convert the mark of out of 10. Okay. So let's say you got 16 out of 20. Then in mid-semester component, it will be considered as 8 out of 10. Okay. Only offline. Unless you have a specific reason. Because see, all students are coming for remit examination of GTU offline. All students, I know that all students are coming to the campus building also, right? So I think there should not be a big issue when it comes to, because class test anyway, it will be considered towards mid-semester examination. So you are already appearing in offline in mid-semester examination, right? Fine. So let us continue with the associative property. Yes. Syllabus, no, I say after class test 1, whatever we have discussed in unit number 2 and unit number 3, 4. Fine. Don't worry, I will ask Professor Wade and publish the detailed syllabus today. Fine. Though it is quite evident, but still I will publish the syllabus today. Okay. Next is the, okay, there are a lot of okay. Out of station hai hoy એના માટે out of station બધા out of station જ છે ભાઈ. તમે GTO ની એક્ઝામિનેશન out of station હતી તો ક્યાં આપી હતી? For example, you are out of station. If there is a GTO remit examination at the institute, will you come or not? It's a descriptive one, so naturally I cannot conduct it online. Fine. See, you can look into it, that whether you want enrollment of hostel or not, that is up to you. Okay, I'm not forcing you to stay in the hostel, or I'm not forcing you to do anything, but please, for sake of transparency, we need to conduct this examination offline. Okay. Otherwise, I would never know if anybody is having a book open in front of him. Right?
Hello, sir.
Yes.
હું છે ને મારા વિલેજ આવ્યો છું સર, એટલે ગુરુવારે આવીશ સર.
પહેલા મેં 15 દિવસ પહેલા ઓલરેડી ડિક્લેર કરેલું હતું, રાઈટ? આ 15 દિવસ પહેલા ડિક્લેર કરેલું છે, 8 તારીખનું ડિક્લેર કરેલું હતું, 8 તારીખમાંથી તમારી એક્ઝામિનેશન ને લીધે આપણે પોસ્ટપોન કર્યું છે, હવે 15 છે, બરાબર છે? તો હવે
યસ સર,
તમે
ખ્યાલ છે મને.
ગામડે જાઓ કે તમે પછી બીજે કશે જાઓ તો તમે મિસ કરશો એક્ઝામિનેશન.
સર તો ઓનલાઈન નહીં આપી શકીએ?
હા,
ઓનલાઈન સર.
ઓનલાઈન નહીં થાય ડિયર, ઓનલાઈન નહીં થાય.
પર સર ઇવેન્ટ છે એટલે આવ્યો છું.
See, તમે ગમે ત્યાં હોય, at least for that day you need to come to the institute. If it is mid semester examination held by the department, right, that is exam.
ખ્યાલ છે, ઓલી વખતે ઓફલાઈન જ આપી હતી ને સર.
Dear, if it is a mid semester examination held by exam department, will you come to the institute or not? Or will you request to stay online? Can you do that? So whatever is the policy adopted
સર
by
Sir.
exam department, right, till July 30, we conducted all examinations online. So I allowed you last time. Now we are conducting offline. So I'm asking you to come here. It's that simple. Okay. So as I said, unless you have a very valid and specific reason, I will not allow you to appear in
सर पर 200 किलोमीटर दूर हो सर, इवेंट है इसलिए, वरना उस बार तो ऑफलाइन ही दिया था ना.
Dear, by now you should have found the accommodation. Right? It is applicable to everybody, right? All students of all universities. No, it will not work. If you share railway ticket to me, that's saying that, oh, I'm out of station, I cannot attend, that will not work. The purpose of class test is to not violate the guideline. Okay. The purpose of class test is very simple, that you have to prepare in short syllabuses so that you can prepare it well and write it well in the class test. Instead of one mid-semester examination where I ask 40 or 50% of the syllabus, which is difficult to manage in this course, I'm just dividing the syllabus into different parts. It is a kind of continuous evaluation. Why can't you appear? I don't know. Fine, it's enough of this discussion. So that's what I'm saying, Samir. That's what I'm saying. If there is a GTU remit examination, you are coming offline. If it is a mid-semester examination, you are coming offline. This is also mid-semester examination, dear. The only difference is I am conducting it.
હેલો સર.
Yes.
હેલો. હા એ સર બધું બરાબર છે, પણ આપણે આ એક પેપર માટે એટલું કઈ રીતના લાંબુ એમ ત્યાં આવી શકીએ? કારણ કે મિડ સેમ ના બધા પેપર એક હારે હોય તો અમે ત્યાં વ્યવસ્થા કરી શકીએ. હા, એક પેપર માટે કઈ રીતના આવી શકીએ?
So you better come every day instead of one paper or one day. Anyway, within few days we are going to conduct all sessions offline. Then at that time you have to come. It's just a matter of few days. Okay. I'm not insensitive towards your issue, but if I try to entertain everybody based on the reason that you are providing, okay, I can never conduct anything offline. and I'm also answerable, right? Fine. Next is associative property. I wanted to announce that your class test will be held. Okay, and I will also announce the detailed syllabus. Now it is up to you. Okay, associative property is useful property of convolution. Once again, if there are two systems connected in cascade, understand? Last time, two systems were connected in parallel. Okay, this is applicable to, just a minute. This distributive property is applicable to those systems which are connected in parallel, right? Now you are aware of parallel connection and the cascade or series connection of the system, right? So I don't need to explain it again and again. These are two systems connected in parallel. Okay, so distributive properties are for parallel connected systems, and here there is an associative property, and this is for systems which are connected in series or cascade. Okay. So this is H1 of n, H2 of n, and X of n is given as an input. This is the Y of n output. So it is basically LHS, left hand side. Okay. Whereas here Wn is what? It is X of n convoluted with H1 of n. Then you will get Y of n. Fine. So now this is for right hand side. And both are equal. Both are equal. Or you can also write it like this, that if you have two systems connected in given in cascade like this, okay, now H2 of n and H1 of n is also possible. That means you can interchange. Here it is H1 of n and it is H2 of n, right? So H1 of n comes first and H2 of n comes second, right? Instead, here, if you see, then H2 of n comes first and H1 of n comes later. Now this is what commutative property. Fine. So that means you can interchange the order. If there are two cascade connected systems, you can interchange the order. Still, the output will be same. Okay. Now, the causality for LTI systems. What is causality for LTI system? Fine. We have already discussed the properties. Now we will discuss causality. Okay. So the impulse response of a causal discrete time LTI system, causal discrete time LTI system satisfy the condition this, that H of n is equal to 0 for n less than 0. That means if the impulse response of the system h of n is equal to 0 for n less than 0, then you call it causal discrete time LTI system. Understand? What does it mean? It means that, let me show you. It means that if you have n 0, 1, 2, 3, 4, -1, -2, -3, -4, and so on, then let's say this is h of n. It is 0 for -1, -2, -3, and -4. Fine. So it means that h of n is equal to 0 for n less than 0. This is the meaning. So then the system is called causal discrete time LTI system. Fine. So what does this mean? It means that impulse response of a causal LTI system must be 0 before the impulse occurs, because the impulse is defined as, this is delta of n, it is 1 at 0. So impulse occurs at 0. How can the impulse response, that is response of the system when impulse is applied? Understand? What is impulse response? When you apply this to the system and the output that you get is your impulse response. How can impulse response exist before the impulse is applied? Understand? Fine. So that means impulse response of a causal LTI system. I'm talking about causal LTI, that means all physical systems. By the way, let me rephrase. All physical systems are causal in nature. Right? This is what we studied in chapter number 1, unit number 1. Right? That all physical systems, that means system that world exist in this world, they are causal in nature. Right? Now, this means that the condition which we applied, y of n is equal to sigma k is equal to -infinity to infinity, x of k, h of n minus k. Now, instead of this, you can also write h of k, x of n minus k, right? We have already seen this in first few slides. Okay, now h of k exists only for n greater than or equal to 0. It exists for n greater than or equal to 0. Right? So, yes. Because it's a causal system.
That is this K. Say n is greater or equal.
Here this n, if you change the variable, it will become k. Instead of n, if I write k, instead of n, if I write k, it's the same. Okay? Fine. K is a dummy variable. I told you earlier that in convolution, we take k as a dummy variable. Right? So k is there. It means that this is revised from 0 to infinity. So whenever you are trying to find out the output of the system, which is causal, then your convolution sum will start from 0 and it will go up to infinity. That's the overall point. Fine? Okay. So this was causality of the system. Fine. We were talking about causality for the LTI system. And now we are talking about stability of DT-LTI system. I think we have already studied the stability in unit number 1. So I will quickly revise it. Fine. A system is stable if every bounded input produces a bounded output. We call it BIBO stable. We call it BIBO stable system. Fine. Every bounded input produces a bounded output. Then you call it BIBO stable system. Now consider an input x of n that is bounded in magnitude. X of n is bounded and it is b. Let's say its amplitude is b. Okay, it can be anything. Earlier we took mx. Now suppose that we apply this input to an LTI system with unit impulse response h of n. H of n. So h of n is the impulse response. Using the convolution sum, we obtain the expression y of n is equal to magnitude of sigma k is equal to minus infinity to infinity h of k x of n minus k. Fine. Now, if you split it, then you can write it as y of n is less than or equal to sigma k is equal to minus infinity to infinity h of k x of n minus k. Now, as we know, x of n minus k is having maximum amplitude of b. And still we have this sigma k is equal to minus infinity to infinity h of k for all n. Okay. Now, this is finite. So, output y of n will be finite if and only if this summation sigma k is equal to minus infinity to infinity h of k is less than infinite. Okay. B, that means input is already finite and it is having amplitude b. So the output will be finite only if the second term is also finite. Otherwise, for example, y of n is equal to 2, this is finite, into infinity. What will be the output? Infinity. So both the terms must be finite, right? Then only the output is finite. So first term is known. This is the condition for stability. Understand? This is called stability of discrete time LTI systems. Okay. Now, if you have any question, you are free to ask. Yes.
Why you do define time shift for this?
Shifting property. Okay, okay. Shifting property is very simple. Because it is quite obvious. Shifting property says that if the input is x of n and it produces the output y of n, right? So y of n is equal to x of n convoluted with h of n. Now, if you, because it's an LTI system, remember, it is an LTI system. What is LTI? Linear time invariant, or linear, in case of discrete, we call it linear shift invariant. Okay. It is also known as shift invariant. Fine. So x of n gives you y of n. Y of n is equal to convolution of x of n and h of n. Right. Now, if x of n is shifted by k, then output will also be shifted by k. Right. This is the property of linear time invariant system. So that means y of n is that means y of n minus k is equal to x of n minus k convoluted with h of n. Understand? Fine. Also, y of n minus k is equal to x of n convoluted with h of n minus k. That is also possible. If the impulse response is shifted, then also the output will be shifted. And if the input is shifted, then also the output is shifted. Understand? Yes? Okay, just a minute. Yes.
Sir, could you please
Yes.
go back to the shifting property you just showed? Could you please go back to this slide you showed the shifting property?
Charles, you are not clearly audible. Can you write your question? Okay. And others, please write your enrollment number. Those who are attending online, enter your enrollment numbers.